To get started with the solution pattern, below is a list of prerequisites. One is have access to an OpenShift environment, preferably 4.10, OpenShift CLI installed on your local machine, Ansible installed on your local machine because we'll be leveraging Ansible to automate all the installations. And in order to use this guide so that you can directly copy paste the command from this guide onto your terminal, there is a these are a list of steps that need to follow. First, log into your OpenShift console as admin user and click on copy login command. Log in with your admin credentials and hit on display token and copy this. Log in with this token and then navigate to your terminal and copy paste the command. This should set you up for the lab to run any other instructions. Let's go back to our next set of instructions and see what we have to do. So once you are logged in, you have to copy paste this command so that you get the value for the ingress domain value of OpenShift. So I'm going back to my terminal. There you go. There's other ways to get it, but this is probably the easiest way because you'll be using terminal anyway. So copied this value and pasted here, and now after I hit enter, this should kind of set up our guide and auto populate a lot of comments that commands that we'll be using for our solution pattern. So next, to set up this environment, we have to run an Ansible script. First, we have to clone this repo locally. So I'm going ahead and cloning this repo. The repo is cloned, and navigate to this specific folder, which is Ansible. And finally, all we have to do is run this Ansible playbook command, which will deploy all the components needed on our OpenShift cluster. There you go. This should take a few minutes, say 25 to 30 minutes. So give yourself some time and come back before you jump onto scenario 1. All right, once your Ansible playbooks have done their execution and once everything is configured, let's look at the architecture and what actually happened, right? So we have Travels company, which is kind of a travels agency, right? With a bunch of microservices running in their environment, and different business units own these different microservices. So one is their online channel business unit, and the other is their travel agency business unit. The online channel business unit is a collection of web portals from which their customers can book flights, hotels, cars, insurances that are deployed in different countries. And the travels agency is basically the microservices which provides APIs that provide details about the availability of flights, hotels, cars, insurances. So the online channel business unit makes API calls to all the services in the travel agency business unit to get the details and show it to their customers. So that is the setup. And because we have a lot of microservices, managing them, observing the interactions between them, and kind of seeing the interactions between them kind of becomes very tough, right? And that is where we'll be leveraging service mesh. We'll manage all these microservices as a part of service mesh, and that is going to be our scenario 1 on seeing how service mesh will improve the observability and also provide more visualization into the microservices. Right, now let's jump into our first scenario. So our Ansible script has already deployed the Travels application, configured Service Mesh to manage all the microservices that we spoke a couple of minutes ago. And in the below steps, as a part of scenario 1, we shall learn how Service Mesh increases the observability and tracing across these services. So let's go ahead and log into our OpenShift console where Service Mesh is installed. You can see all the components of Service Mesh, but our things of interest here are Kiali and Jaeger. So let's go ahead and click on the Kiali route and let's navigate to graph. So with the graph, you have to select the namespaces first, and you can see how the different microservices, the direction of calls here. And if you want to see actually real-time distribution, we actually have a simulator which generates the calls. So let's go ahead and check the request distribution. You can actually see how the requests are distributed among different services with the percentages. You can also see the flow of traffic with traffic animation option. And this is how actually Istio increases the observability into the services. It also provides a lot of other details, right? If you go into the workloads, click on a specific workload, you can check the traffic, the logs, the inbound metrics, the request volume, request distribution, and whatnot. So this way Istio provides a very in-depth insight into your microservices and the interactions. And if you want to trace the microservices, trace the different calls, you have to go back to and click on distributed tracing, which will take you to the Jaeger UI. And that is very interesting because it shows you, the time taken between different calls and how the different services interact, and which is kind of the bottleneck you can figure out, right? So let us go ahead and select, for example, say the hotels travel agency, and let's find the traces. So it shows all the different traces. Let's go ahead and click on some trace here. You can actually see the amount of time taken between the different calls, how the call is traversing amongst the different services, and this is the level of visibility that Jaeger provides. So you can actually see all of these things in the Jaeger UI, and you can select the different the you can select the different services here, you can select the different operations here and whatnot, and get different types of tracing details using the Jaeger UI. And again, remember, all this is possible because Service Mesh, OpenShift Service Mesh provides this out of the box, and because all these microservices that we're able to trace and observe are managed by the Service Mesh. So now let's jump into the second scenario where we discuss about opening API access to external partners. So Travels as a company has been seeing a lot of demand from their partners who approach them to open up their Travels APIs so that the partners can leverage it to build more value added services. Travels obviously saw this as a great business expansion opportunity, but at the same time wanted to expose their APIs in a more sustainable and secure way. So, in order to achieve that, the strategy Travels devised was, they wanted to deploy two different versions of the Travels microservice, uh, where the version 1 served the internal traffic, and the version 2 would serve the external or the traffic that is coming from partners, which means they wanted all the partner calls, API calls, to flow through V2 and all the internal calls to flow through V1. And for this, they didn't have to do anything extra or didn't had to install any additional components. They decided to leverage the intelligent traffic routing capabilities of OpenShift Service Mesh for this, and in scenario 2 we'll be doing exactly that. So first, let's go to our OpenShift admin console and get the login command. Let's do display token. Let's go to this login command, Control C, and login. Here you go. Now we are logged in. Now we can run our OCCLI commands directly from our local machine. Let's go back to our instructions, and first let's deploy the V2 version of the travel service. Go ahead and have a Kubernetes manifest file that will deploy my V2 in the Travels agency namespace. So once this is deployed, if we go back to our Kiali and observe, you can actually see the traffic is being split between V1 and V2. Let's just give it a couple of minutes before we can see what's actually happening, right? But before that, before we see that image, what exactly is happening is that, Service Mesh, when it sees a second version of the microservice, it decides to split or load balance the traffic that is coming to that service between the two different versions if there are no other rules. So eventually what you'll see is, the traffic is being split between V1 and V2. You can see eventually these numbers will become 50-50. This is happening because, we've not yet told Service Mesh that, V1 should go V1 is only for internal and V2 is only for external. What all we have done is we've just deployed the V2 version of the travel service, and next we are going to direct service mesh to take the action where it will strictly route all the internal traffic to V1 and external to V2. Let's see how to do that. So now after we've seen that, let's go ahead and deploy what we call a virtual service, which will actually tell service mesh to, send all the internal traffic to, you know version 1. So let's go ahead and apply that. And now if you go back to your Kiali portal and wait for a couple of minutes, you can actually see, even now you can actually see the traffic going down for V2, because the traffic simulator that we currently have is generating traffic exclusively from the internal portals, which is VIG, Voyages, and Travel. And as we can see, the number of calls made to the V2 is going down, because we've service mesh is telling any calls that are coming from internal portals will only go to V1 and not to V2 anymore. So we've made that rule. So you can see eventually you will not be able to see V2 in this graph as you keep refreshing and give it a couple of minutes. Eventually you'll not be able to see. So I'll just keep refreshing until we see 0%. So it's 7.6 right now. There you go. So you cannot see V2 anymore. That's because all the calls that are coming to the Travels API are only coming from internal portals, and hence are only going through V1 because of the virtual service that we just deployed in service mesh. Now the next step is to tell service mesh, or is for service mesh to tell that any traffic that is coming from external partners should go through V2. So we have to do two things here. One is expose our API externally. We can do that using the by using the Istio Ingress gateway, and also creating another virtual service which will redirect all the external traffic to V2. So now let's go ahead, copy these both OC commands and apply them. There you go, apply. And now you have to go back to your instructions and check if you can actually access the API externally now, because service mesh has exposed the API through the existing inbuilt Istio Ingress gateway. You can actually access the API. External partners are now able to access the API. And let's generate a bunch of calls, say 50 calls, that will kind of simulate the traffic coming from an external partner. So I'm going to do that using a curl command and run it for 50 times. And now as we do that, remember we had zero traffic for V2. You can slowly see the traffic being increased for V2. V2 appears into the Kiali graph, and eventually you can see the traffic going up. See, you can see 50-60% of the traffic, because we made a bunch of calls suddenly. And if you keep doing more calls, like if you run the same command another 50 times, you can see the number of calls going up for V2. And eventually once all the calls have died down, it'll go you can see all the traffic goes back to V1, because only the simulator that we have is generating internal calls, and if you want to do external calls, you have to manually generate them. So that's how we are actually intelligently routing traffic through V1 and V2, and service using the intelligent traffic routing capabilities of service mesh. We are able to differentiate the destination of the traffic based on if it's internal or external, and by leveraging the virtual services of service mesh, that is how we're able to achieve it. Now let's jump to scenario 3, where we'll talk about securing API access for north, south, or external traffic. In the previous scenario, we've actually exposed our APIs to external traffic, but one thing that we have not done in that scenario is securing that access. So in this scenario 3, we'll be covering how to secure our access to external traffic by leveraging 3Scale API management. and putting our API behind the API cast gateway that comes with 3scale API management, and authenticate all the partner apps using API keys that are generated by 3scale, and also as a part of it, record analytics in terms of the usage of the APIs by different partner applications. You can see the different partner applications that are trying to access our APIs in the architecture diagram. Here we have the green partners, blue partners, red partners trying to access the API through the API cast gateway, behind which our original backend API is sitting, and is being protected. The API cast gateway in turn interacts with the API manager, where all the authentication information is stored, and things such as rate limits, analytics, everything, everything is recorded. So let's jump into the scenario and see how it's actually achieved. So just a heads up, we've already secured our API using Red Hat 3scale API management. So if the partner apps without any authentication keys or API keys would not be able to access the APIs, and that's what we are going to see first. So this is the Red Partner app that you'll see, which will help you book tickets from their own website. So as you can see, they're not able to access the API, and let's go ahead and explore why they are not able to do that. So we've deployed this Red app on our OpenShift cluster, and let's check why it's not able to access the API here. So let's go to the deployment of the Red Portal app and check the environment variables. Right, as you can see here, it has an API user key value, which, you know, currently there is a placeholder text there. We need to replace it with the actual API key that will authenticate it against Red Hat 3scale, and then give permission for the app to access the API exposed by the travel agency. Now let's log into Red Hat 3scale API management platform and get this API secret so that the the Red app will start working again. So let's first log into 3scale here. The username is admin, and you can get the password by putting this command into the remote machine where you installed OpenShift. This is it. This is the password. So copy the password, and let's go back to our 3scale login and sign up. So the travel demo partner product, this is the API that is managed in 3scale that is of our interest here. So let's go ahead and check our applications here, and when you go there, you can actually see the Red app, and the Red app is registered for this travel demo partner product, and you can see the user key is Red Secret. So copy this Red Secret and replace it in the OpenShift console under the deployments, and hit save. As soon as you do that, the pod should restart, and in a couple of minutes, when you go ahead and refresh your partner app, you should be able to see the list of cities and actually make a booking. So this shows that once you give the API key that is um, allocated by 3scale, the external applications and external partners should be able to access your APIs, and provide all the information that is necessary. So for the other two partner apps, which are the green app and blue app, we've already added the API keys, so you should be able to access them directly. So if you check that out, the green app should be able to show you a list of cities, and once you choose the dates, you should be able to see the list of flights, hotels, etc. Same case with the blue app. So the green app and blue app, we've already added the API keys, so that's why you're able to see them. For the red app, we didn't add because we wanted you to go through this exercise and understand where we are actually getting the API keys from and how you can leverage 3scale API management for that. And another next part is 3scale API management is just not used for authentication purposes. You can also use it to monitor and analyze your external API calls, and you can look at a bunch of analytics on how many calls a certain app has made, and at what time, during what time period, etc. Right? For that, we have to First, emulate a bunch of API calls as if they are made from these apps. So I'll just run this for loop which simulates these calls as if they are made from the partner apps. And once this is run, you can actually go back to 3Scale API management admin portal, the product, and navigate to say the application. For example, let's say the red app, and click on analytics. You can actually see how many calls the red app has made in the last 24 hours. You can check 7 days period if your environment has been up for the last 7 days or so, and get different types of information, right? And not just that, you can also upload your API documentation directly as a part of your CI/CD process into 3Scale API management. And you know, partners can directly check how the API works, what type of input it takes, and try out your API, so that you know they don't have to reach out to you or your engineers on to ask about how the API works. So that's the convenience that 3Scale API management provides. Not just security, it provides information about around analytics. It also provides an out of box developer portal, and all types of information including rate limiting, etc. So that brings us to the end of scenario 3. Now let's check out our scenario 4, where we'll be trying to secure our internal API access. In this scenario, we'll see how to secure our internal API access, and why is it necessary, and how do we do it. So more often than not, you can see huge enterprises have multiple business units or LOBs with varying goals and KPIs. So when one business unit wants to use the APIs that are built by the other business unit, it is better to have a formal relationship. And also it is important to make sure that the external business unit, even within the same company, is not abusing our APIs, right? So it's better to secure that and also track that relationship and have that formal agreement. And that is where, especially if your services are already a part of the service mesh and are managed by OpenShift Service Mesh, the native integration of Red Hat 3Scale and Service Mesh would shine. So for example, in our current example, let's take the travels portal or the online channel business unit, and the travels agency business unit, right? So the travel portal business unit will try to access the APIs of the travel agency, and we'll try to create a formal agreement, a secure channel on how they can access this. We will Our demo will focus on uh, making sure that all the portals which are part of the travel portal business unit will only be able to access these APIs if they have an API key, and that is done through the native integration that 3Scale and Service Mesh give out of the box. So to create this integration, first things first, we'll need a couple of access tokens that will help 3Scale and Service Mesh communicate. So first, let's get the admin access token of 3Scale. Put this in your OpenShift CLI. Get the admin access token. Copy it on a text pad so that you can remember it, and then go back to your 3Scale portal, account settings, personal tokens, and your travel demo internal product, and get your service token and copy it in your text folder. And now let's go ahead and use these secrets in our custom resource file that will create this whole integration. So first, let's copy the whole YAML and come back to our terminal to create the custom resource file. Let's say vim sme internal dot YAML. You can give any name here, but I've just given this, and this is going to be an empty file. Copy paste the YAML that I've copied from there, and get into. So first things first, let us replace the access token here that we obtained. Okay, delete it. Access token, paste. Now let's go ahead and replace the service token with the placeholder text. Let's go back to our text editor, find the service token, and there you go. And let's save this file. And before we deploy this file onto our cluster, let's check the situation in Kali first. So everyone's happy, all the traffic is flowing through V1 from the internal portals, there is no authentication, all the traffic is green. Now as soon as we deploy that YAML, the integration is created, and if the calls are not authenticated, the traffic wouldn't pass through to the APIs, which means this whole graph will turn into red color, right? Which means there's no traffic flowing through. So let's go ahead and deploy that. And there's a command for that, oc apply f. I've just copied it. Oc apply f. There you go. It should create it. Just give a couple of minutes before we can go back to our Kiali portal, and the whole we can see how the traffic turns into red color, because the calls are not authenticated, and the APIs, the whole the 3-scale service mesh integration wouldn't let the API calls go beyond that point because they are not authenticated. So let's go back to our Kiali portal and slowly notice the traffic changes to red color. So as you can see, the traffic will start changing to red color, and the whole graph to the right of the travels will get terminated because there is no traffic effectively flowing. As you can see, the numbers are coming down, and eventually they'll go to 0. So as you can see, in a couple of minutes, the whole traffic from your internal portals becomes red. That means the calls are not going to any the API calls are not succeeding because they're not authenticated anymore. So for that, now we have to go back and add the API tokens the API keys that we obtain from 3Scale through the deployments of these internal portals, so that the traffic starts flowing as such. So let's go back to 3Scale and check what is the token for this, right? So let's go back to applications, listing. Let's check for the VIG app first, and it's VIG secret. So let's go to the deployment of VIG app, and let's go to deployments, travel portal, VIG environment, and let's add a couple of environment variables. One is the name of the API key, and the value of the API key itself, so that the calls are authenticated again. So let's go ahead and copy those values here. API user key name, API user key name, API user key value, and user key, and this is the secret that we got from 3Scale. So let's go ahead and deploy. So as soon as you do this, you will see the traffic flowing from VIG portal will start turning green. Just give it a couple of minutes before you go on to your Kiali to check this. So as you can see, the traffic flowing from VIG slowly turns into green. That means though the majority of traffic that's coming from travels and voyages, because they're not authenticated, is red, the traffic coming from VIG is able to go through to all the different services, because we've just added the API key that we got from 3Scale. So if you repeat the same process for the other two portals, which is travel and voyages, we should come back to a graph which look like the original one with all greens, right? So that should be the goal. So let's go ahead and add these things to the other deployments too. Um, in a couple of minutes, once you're done with adding the environment variables and the API keys that you obtain from 3Scale to the deployments of the internal portals, you should see the traffic slowly turning into green, and eventually the whole graph should turn into green. As you can see here, we've returned to the original state because now all the calls are authenticated via 3Scale. And this was possible because, one thing, it was possible because all the services were part of the service mesh, and we could leverage the native 3Scale service mesh integration. And as a result of this integration, there was no need for us to introduce an additional gateway for the internal traffic. In this scenario, service mesh itself acted as the data plane, and used 3Scale as a control plane instead of deploying an additional API cast gateway in the environment. And finally, that brings us to the end of all our scenarios. Thank you so much for watching the video. I hope you found it useful.